Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, I'm going to be posting a homework solution for TopTechBoy's Raspberry Pi Pico series, lessons number 30 and 31. Yes, really, it's a homework solution. I know it's been 4 or 5 months since I've posted the solution, but here we go. I'm getting back on the tricycle and off we go. In today's video, we're going to be taking the Pi Pico, connecting it to the internet and calling APIs so that we can get data back via JSON into a dictionary and then start manipulating and displaying it. It'll be a lot of fun. Now I can tell you that today's video is not going to be really focused on hardware. Obviously the code is running on my Pico, but there's really nothing to display in this lesson. So everything we're going to do today is going to be done in Thonny. And so I'm going to start this application here. And it's connected to my Wi-Fi. It's the Sunfounder Pico, so it gets the IP of 201. And we have our first activity fetched. Memorize a favorite quote or poem. Oh, too many, but that would be fun. Let's try another one. You can see there's only one person and it didn't provide a URL. Let's see if we can get some that give us some other information. Okay, so play a game of Monopoly, and of course you need more people than one. This recommends 4. Can have more than that, less than that. Monopoly's a fun game if you really have nothing better to do. Let's see if we can get one that has a URL. Memorize the 50 states and their capitals. Well, if you haven't done that, now's a good time to start. Volunteer. Oh, volunteering is a wonderful thing to do. Let's see if I can get an activity that has a URL, though. Make a new friend. Well, here you are. Thanks for watching. There we go. Oh, look at that. I couldn't have scripted that if I tried. Learn how to use an Arduino. Well, there is in fact a URL listed for a Wikipedia site, but this is the perfect time to talk about TopTechBoy's Arduino class that's coming up in just a couple weeks with the Arduino R4 Wi-Fi. Neat piece of hardware. It's going to be a lot of fun. Has nothing to do with this video, but I think it's awesome that it recommended that you learn Arduino, because what a wonderful thing to do when you need something to do. Alrighty. So now I'm satisfied. We got some activities with multiple people. We got activity with the URL, and we can be done looking for things to do. So let's take a look at the code. I posted just up here as a comment to make it easier. This is the API I'm using. It's at boardapi.com, so you can definitely try it yourself. And the code itself is pretty straightforward. I'm just importing the micro requests library. Otherwise, it's pretty much the same as previous videos where I've done networking on the Pico. I'm setting a running flag. That's so I can escape out of the loop by pressing N. I'll show you that when we get to the while loop. And just kind of the standard fare. If we're connected, let's disconnect first. This eliminates the need to unplug the Pico and plug it back in case it doesn't always come up. I have yet to have this fail. I have not yet had it where I run the code and it's unable to connect to the Wi-Fi from a previous connection. This disconnect always cleans it up. So it's a wonderful thing to put there. Then I've got my connecting and displaying IP info. Then once we're connected, now we can actually reach out and start having some fun. So I'm creating a dictionary called activity, and I'm filling that dictionary by taking this micro requests.get to this API, which is returning a JSON file. And then because micro requests has a method called JSON, it's actually taking that JSON and putting it into a dictionary for me. So there's actually a lot of work going on here, and I don't have to think about any of it because I'm giving it a URL for an API and it's giving me back a dictionary with very little effort on my part. Dictionaries have a built-in method called keys to display all the available keys, so I've done that. Just wanted to see what exactly this thing is returning. And you can see I've got a handful of keys. The ones I care about are activity, participants, and link. First thing I'm going to do is I'm going to take that link and it'll return either an actual URL or just null, nothing. And I wanted to make it a little nicer than that. So I said if it returns null, I'm going to put the text none in there. And you saw that and some of my activities that it pulled up where the URL was none, rather than just having a blank space there. Then to print it out, it's just a matter of walking through that dictionary. I'm taking the activity key, the participants key, and then my interpreted link value, and then asking, do we want to go again? And any key at this point will move it forward, but if we press N, it's going to set the running flag to 0. We come up here in the while loop. While running is no longer 1, so we exit out and we get to this goodbye, and the program exits. So that's pretty straightforward, but to be honest, kind of pointless. Let's do something that has maybe a little more value. So I'm going to do, I'm going to look at weather data. Let's look at weather data. And so I'm going to, once again, it's going to disconnect and reconnect. So I'm going to get a clean connection. And let's look at the weather for a particular station. Now, I have not memorized these. I have a piece of paper in front of me with the various airport codes around the United States. So let's take a look right now at what the temperature is at Chicago O'Hare Airport. And when I put in the airport code, you see I get a URL. I put a URL on the screen. This way I can actually click on this. Well, I'll do that in a second. I'll walk through this and then I'll show you what happens when I click on it. So the first thing I wanted to grab is the actual raw output. This is what's called the ASOS output, the Automated Surface Observation Station. This is the code that it spits out, and it's actually not as tedious to read as it looks. We have the station identifier, the timestamp, the wind conditions, the skies conditions, and this one has a few sky conditions, then the temperature in Celsius, temperature, dew point in Celsius, air pressure, and then we have this RMK, which stands for remark, and this is where we can just get all kinds of random observation data, and we don't care about most of it. I just wanted to print this out because I wanted to see, number one, because I kind of know how to read these, I wanted to see what the data actually said, and then I wanted to see how this API really did at interpreting that data. I've gotten some pretty interesting results, but we'll look at the JSON in just a little bit, and you'll see why I'm curious about that. So here we go. Current weather at Chicago O'Hare is cloudy. Here's the timestamp, when this observation occurred. Temperature is -4. Dew point is -18. I think that says 18. Oh, -10, I'm sorry. Couldn't read my monitor properly. And then the wind, direction, speed, and whether it's gusting. And so let's pop in another one. Let's go somewhere a little warmer. Let's go to maybe Honolulu. Let's see where we can go with that one. Let's see how warm it is in Honolulu right now. It is 25 C. Well, I'd definitely take that over -4 in Chicago. Mostly clear skies. Sounds like a great place to be right now. Because this is using an API with the National Weather Service, it's specifically limited to United States stations, but they do have a few territories, and one of those is the Virgin Islands. So this is about as far south as we can go. The airport in the Virgin Islands, let's see what the temperature is there right now. And this is what I was talking about. Sometimes this data comes back a little strange, but I can read here in the ASOS output, we're at 27 C temperature. So that's nice and warm. That's about 90 Fahrenheit or upper 80s Fahrenheit. My math's not good. Reasonable dew point, etc. So let's take a look. This one will be really interesting. So I'm going to click on this URL, and we're going to look at the actual data that's output. And as we can see, I'm sorry, I'm looking at the other screen because it's a little hard to see on the screen in front of me. We have this JSON file, and there's multiple keys. There's a lot of nested keys. So for instance, to get the temperature, it's under properties, temperature, and value. And why this is null, I'm not quite sure. This is processing on their side of it. The National Weather Service is pulling in this string right here, and doing the processing on it to produce the rest of the JSON file. And not really sure why their processing is giving us null data, but it does happen. I just wanted to show that and kind of how we have to accommodate bad data from public APIs once in a while. So let's take here, I'm going to come down here and properly quit the program. Oh, that's not it. That's going to crash it. Oh, well. Oh, nothing ever goes perfectly, right? All right, so let's walk through this. So it's just the same setup with the libraries and my running flag and my Wi-Fi connection and all this kind of stuff. So now we come down here and we bring in the station ID. And again, these station IDs, these are airport codes around the country. And no, I have not memorized them. I have a sheet in front of me so I can do this video and check on weather around the country. I've got Chicago, Dallas, San Francisco, a few others around the country. Then I want to print out the URL because just like you saw, I can click on the URL and inspect the JSON, especially if I don't get the data I'm expecting. This API, so this is kind of interesting. Everybody has different rules for their APIs. This particular API, they need a user agent string and an email address in order to trigger the API. And so I made up a user agent called MicroPython and used a invalid email address. Seems to work. That's fine. There's an FAQ regarding this API in terms of how frequently you can hit, respond, or I'm sorry, how often you can send requests to it and get a response without getting blocked. And they're very tight-lipped on that number. However, there's kind of a hint that it's multiple times per second before you get blocked. So with my little program and doing, one request, maybe 2 or 3 requests per minute, I have no chance of getting blocked. So I'm just fine using this as my header. Then I'm going to once again do this current OBS. OBS is observation, current ops, creating a dictionary again with a micro requests exported from JSON into a dictionary. And now I'm just going to walk through that dictionary and print it out. And again, you can see there's this properties key, and then there's keys nested under the keys. So I have my raw message, which is that ASOS output, and description, which is, what is the sky condition, clear, cloudy, etc. Timestamp, temperature, and this is where I showed its properties, temperature, value. So we have actually 2 keys nested under another key to get that data. And again, the missing data there, that's not on my side. That is on the National Weather Service's API, not translating correctly and not putting the values into the JSON file correctly. And then I just do, if it's Q, I'm going to set the running flag to 0, come up here, and we exit out to the goodbye string. So, all right, I hope that was somewhat interesting. It's been a while. I'm a little rusty at doing homework solutions, but hopefully I'll get better in the near future. Look forward to getting into the next lessons where we're going to take this weather data and actually start doing some fun visual displays with it. And I'm looking forward to that. I hope you are too. Look forward to seeing you there. For Simply Brian Enterprises, this is Brian, and thank you for watching.